Thank you. As mentioned, I'm David Cotten. For those of you that don't know where Oak Ridge is, it's about 15 minutes to the northwest of here. So we're really close. It's pretty much a suburb of Knoxville. And what I'm going to do today is talk about not only national security sciences at Oak Ridge, but also the lab as a whole and how the national labs fit into a lot of the work that people are trying to do here and fit into the general research goals of our community. So some of the stuff I'm going to go over are a lot of things that I learned because I came from the University of Georgia and didn't know much about the national lab space. But at universities, there's a lot more of the basic science. You're trying to just understand these hard problems to the fundamental level that may not have a lot of reward, but you just want to see, will something work? You know, is it feasible? Let's work at that. Then you have the industry side, and there's a lot of industry partners here that want to, make the most highly engineered product available, that it works as much of the time as it can, and then that it can be moved to serial production. While the national lab, we're kind of in that middle ground that we want to do basic science, but we do not manufacture. Right when I started, they said you're never going to build more than 5 or 10 of one of the devices you make. If you get it to that level, it needs to go off to a project partner. So some of the things and focus areas that Oak Ridge focuses on, I'm going to go now from a really large scale view of what Oak Ridge does. Number one, it started in the 1940s with the Manhattan Project of enriching uranium, and that's where a lot of the research still lies with neutron sciences. We have the spallation neutron source is one of the best neutron sources that you can get in the world, and that's where a lot of the research that we still have. And you'll see all these focus areas. The lab is about a little over 7,000 staff members, so it's pretty large. The keynote speaker talked about exascale computing, the national lab. Oak Ridge has 2 of the top 5 supercomputers in the world right now. We have Summit and Frontier. We have a lot of material science that people don't know as much. We have an additive manufacturing facility that is gigantic and just off. It's not at the main campus of Oak Ridge, but in Hardin Valley. Still do a lot of fusion energy, going back to the roots of the national lab. And then since we are a DOE lab, there's a lot of energy systems research that we're doing, from battery technology to clean energy. There's also bio and environmental research. We have people that actually are doing a lot of phenology for plants, or even biometrics, or even biomedical work. And then isotope R&D production, and then tied to what we do, and I'm going to do a deeper dive into this, which is national security. And the big thing with national security, remember, is that it's not just physical threats. That's one of the number one things, but also we're doing a lot of work to better understand cyber attacks. Like, what are some vulnerabilities that may be known throughout the United States that could cause issues? How can we help identify those vulnerabilities, help resolve them, and help keep our nation secure, as to say it. Natural disasters. A lot of people don't think of that when you're thinking of national security, but if you have a large hurricane or wildfires, they could knock out the power grid, they could affect hospitals. They're affecting the nation as a whole and the security of the nation. So we focus on that. Non-proliferation, I'll go into that a little more specifically later, but we lead the world in understanding how to create and transport nuclear material safely and to understand where it's going. And then infrastructure vulnerabilities of making sure things that we connect to the grid or the grid itself are secure and working properly, because if you have a power outage in one spot, a lot of times it can cascade and affect numerous other areas and can take a long time to come up. So diving deeper into the sections of national security, where we have reducing nuclear risk. I already touched on a lot of this, but one of the big parts of this is the international safeguards and policy that not only do we help make sure that nuclear material is being transported safely, we are setting the guidelines for the world of if a European country wants to move some material, they follow a lot of the safeguards that we laid out. We also have a mobile uranium facility that if there is a spot that you found nuclear material somewhere, it could be deployed and help solve the problem efficiently, make sure that it's cleaned up and runs smoothly. Securing critical assets, that's another area that we focus on a lot. I've touched on this a little bit, but a lot of this that I want to focus on for this part is cyber physical security. So understanding, what are in the chips that we are using, whether it be in the manufacturing sector or even at home, what's in those chips and how can we understand what are they capable of and what vulnerabilities they may have. So a lot of the stuff you'll see, I keep saying vulnerabilities, a lot of it is, we do a lot of work to see, is this piece of equipment that people are using, a lot, is it working the way it should, and are there the correct safeguards on it to ensure that national security is kept in mind. Manufacturing, the additive manufacturing facility that I talked about is one of the world leaders in various composites, but also building materials for extreme environments. And a lot of companies come into the lab and they work with Oak Ridge at this additive manufacturing facility to better understand how they can solve these difficult problems, because it's usually high heat, high stress, very complicated pieces of equipment, and then we pass that technology on to the company and they go off and they can manufacture it and keep moving forward. We do a lot of, and tied to that, we have to do a lot of modeling with that, and that's tied to a lot of the HPCs, because you have to understand how these different compounds are going to work together and the different stress factors that can occur, and then you model it, and then they build it and put it through stress tests and repeat the cycle. Advancing human security, that's where I sit in, where I lead the Resilient Communications Group. And a lot of the work that we're doing is we're working with the autonomous systems team to be able to just understand the RF environment, use machine learning to help solve some of these problems and help ensure that, there's efficient spectrum sharing going on. Diving into a little more of the core capabilities that we have here, we work with probably almost every vendor here, at least at some point, if not directly right now, we have in the past with their software-defined radios. We do a lot of protocol development and protocol and waveform development, and trying to better understand what protocols are out there, what are the vulnerabilities around those, and how we can work together with different vendors. The resilient adaptive communications, that's some of the work we do with a lot of GPUs and neural networks to actually be able to adapt and effectively share the spectrum, and that ties into learning from signals. We have a small satellite ground station on site that we can downlink UHF, VHF, S-band, or X-band frequencies, and that's tied to our high-performance computing platforms. We don't utilize that as much as I'd like to right now, but we're looking for ways to expand that possibility. And then we also do a lot of work with commercial partners of pushing technology to where the commercial partners can use them and advance them to the greater sector. Let me make sure, check my time. All right. Some of the thrust areas we had for the small satellite ground station was we want to work with these small sat companies that are developing new sensors, all these image products, but they don't have in mind a lot of the security or or onboard processing that could be done, or geo and assurance is one of the words, which is making sure if they collect an image that it goes down to the end user and it is still the same image, that nothing has occurred to it. So we're trying to work with them to be able to strengthen those areas using the systems that I've already described here. What's nice about the ground station is, besides the bands that I've already described, is it's been built in a secure location that, as in on top of the building, that's directly connected to high performance computing, but it can be expanded. We've looked into expanding to optical communications, working with a quantum team on site, possible KA configurations, or even phased arrays. I touched on both of these a little bit. It looks like, okay, well, one of the image figures did not come up for software-defined radio. Oops. But for the geo and assurance part, a lot of it is we're looking at using software-defined radios with neural networks and GPUs to just quickly and adaptively learn from the signals that we're receiving. I'll just leave it at that. And then for the emergency response tied to the ground station is we're working with synthetic aperture radar, small sat companies to actually build data products. A lot of this is focused on emergency response, say from flooding or hurricanes or wildfires, and to quickly be able to get their data, produce some sort of usable product, and get it out to emergency responders a lot more quickly, because right now it's just reliant on the small set companies, and as a whole, they just want to put down an image, and if you see the gray images over there, that's what synthetic aperture radar looks like, and if you're a radar expert, you can read that, but a typical person cannot understand what you see in that figure. So we're helping to produce products that are a lot more easily used and disseminated. One of the last focus areas I'm going to talk about is we've been moving into IoT devices and looking into those a lot more in our lab, in our group, and just it's proliferated. You know, you can go into your house and maybe your refrigerator or your washing machine is hooked up and connected to your network, and how do you know what is secure about them, how are they accessed, and what can we do to better understand the vulnerabilities of these systems? And this actually ties directly into UAS. So a lot of UAS platforms are becoming more prevalent, and they use many of the same protocols as well. So we're investigating those areas to better learn their vulnerabilities. And the last thing I'm going to cover, because I think I'm over time, is we have started this NSSD Academy at the lab, which is to try to bring in more graduate, undergraduate students, and even K through 12 students to start to experience what it's like to be in a national lab, do some of the national lab research. But I put up this specific figure because when I was getting hired in the lab, I thought it was all PhDs, that's what you did at the national lab. But you can see it's almost a third in each category of people with just undergraduate degrees, masters, or PhDs, which I found to be very interesting and very helpful because we, have very intelligent people at the lab. And the last part is what I was already introducing to, which was the academy path. And we're trying to create different pathways to get people into the lab, whether it's we go to high schools and just do demos and talk to them about it, understand what, something like GNU Radio can offer to them and get them just to play around with SDRs. Does that lead to a path of national security? Maybe, maybe not, it doesn't matter. They're learning those skill sets. And then we're also working with community colleges, different undergraduates, retired military personnel, and even other government partners if people want to come and work at the lab. Thank you.